Hi, this is Stephen Brower from Rat Valley Community College. This is a draft, but I might end up publishing it anyway. Macros is something we're supposed to be taking a peek at, and what I want to show you is how we can write our own to make our lives easier. Okay, so this is this procedure right here, display signed int array, receives three parameters, ESI, ECX, EDX, and the idea is it's the address of an array, the number of elements in the array, and then the address of a string to display before the array is displayed out. And so then the calling of this, it's the ESI, ECX, and EDX has to be loaded. So it's similar to, there is a dump mem that the author has provided in his library, and that dump mem has a series of registers that are loaded. These are different registers, but just the idea is those registers are loaded, and then you go call the procedure. Well, the idea of writing a macro, right here, this is a macro, and what happens at compile time is every time the macro call takes place, this code is put in its place with the values filled in based on what was in the code. Meaning, if I just scroll down to here for a second, here's the call of the macro, and you'll love this. This looks closer to Java because the parameters are comma delimited. So this would be the string to display before the array, the address of the array, the length of the array. That's what's being passed to this macro that's up top, the mdump int array. So the mdump int array, and we'll focus on this just for right now. That's the call, the procedure that I had down below. And then here's the setup of the registers that it needs. What it's doing is it's taking the parameters that are being passed in, and it's using them for setting up the registers, so that this item count is being, so this is the name of the parameter, item count, is going to ECX. The address of the array is going to ESI, and there actually would be actual text that would come in. That text we're actually making a string out of by adding the 0 at the end. And I don't know if you notice, if I come back here, this is not a null terminated string. This is just a string. So what this macro takes care of is sticking the 0 on the end for calling that, or adding the 0 on the end so it's a null terminated string. So the idea is that we can call this macro that we wrote. It does the register setup, and so that this way calling this macro is easier than doing like this, all the loading of the right registers, and then calling the procedure. So in terms of writing a macro, we can use a macro as a wrapper. That's one of the reasons why this is named wrappers, around, in this case, a procedure that we wrote. So a macro that we wrote to wrap around a procedure that we wrote, so that the calling of the procedure can be easier by calling the macro instead. And so, when we call the macro is calling the procedure. The procedure is expecting the registers, but here we're just comma delimiting in the values. Okay. Now, those two pieces I just showed, nothing special has to be added to the file in order for that to run. But remember how up to this point we have been doing include Irvine32.inc? Well, guess what? The author wrote some macros for us. And by him writing some macros for us, he wrote his own wrappers around his own procedures. So the calling of his procedures are a little bit easier. Now let me, if I did this right, run this. So first I'll run it. Think about the commands that we'd have to do. This is prompting for a string. Remember in an earlier lab we did the read string, and we had to set up a number of registers to call read string, so that what the user types in would get placed into the proper place in memory. And here, the same thing, it's another read string that's taking place. This here just had two different dumps. The second one right here, that's the one of the write-in that I had. Okay, if I can, let me leave this open, scroll through the code. Remember up to this point, we've been doing move EDX, offset, a string, call write string. Well, the sample macro program that's displayed here, M standing for macro, M write line, sample macro program. And then this prompt here for enter your first name, M write, enter your first name. And then when it actually prompted me for my name, M read string, first name. So the author wrote some macros that makes the calling of his own procedures a little bit easier. And so in terms of, if I scroll back up here to data, all of these strings that were being referenced here throughout this main procedure don't have to be defined here because they're being defined on the fly by us calling the macro. Now there is, in a sense, a little bit of overhead because that means the lines for MWrite line are copied in here. The lines for the MWrite are copied in here. The lines for the MRead string are copied in here. And so what happened is the procedure gets longer. If we look at the LST file, the LST file would be significantly longer than what we're seeing here. So there is potentially a performance hit. And if we are worried about, let's say we do have a loop using the loop statement, it's possible that it looks like it's a small loop, but it ends up being much larger because that we're doing the jumps. So what's the point? What is the point? For using the author's macros, you can include macros.inc, and then you can call his macro names to make things like displaying on the screen, prompting strings, to work a little easier. So that's one thing we can do is use the author's macros. The other thing is we can write our own. So the macro that I wrote here for calling my own procedure just makes the calling of that procedure easier. So instead of having to call display signed in array, all I have to do is call this macro, the mdump in array, and I can pass in the string, the address, and then the length. Yeah, it's a train wreck. It was supposed to be a draft, and we ended up posting it.